Okay, from right across the bay in Oakland, California, we have Biotics AI. Presenting for Biotics AI is Robbie Bushami and Shaskin Saroff. Give them a round of applause.
My name is Robbie Bastami. At Biotics AI, we're using AI to detect fetal abnormalities. I set out to build a platform that improves the overall quality of diagnostics and makes sure that every single pregnant patient gets the quality of care that they need. I was raised by a family of obstetricians. My mother, her sister, her brother, all worked in maternal care. My mother passionately worked to improve the quality of maternal outcomes in her home country of Yemen as a physician and as a Berkeley researcher. As a kid, I fell in love with coding at 9 years old and later grew to become an AI engineer. But growing up around my mother's work, I became acutely aware of the growing problems in pregnancy care. $16 billion are lost annually in the United States alone as a result of preventable maternal complications. With the increasing shortage of OBGYNs, the growing rate of pregnancy complications, and with new legislation negatively impacting maternal diagnostics, it's becoming more difficult to identify these problems earlier to prevent tragic outcomes. In the developed world, half of pregnant patients with a fetal malformation are misdiagnosed due to an error by an ultrasound operator. Globally, 107 million mothers do not have access to the minimum standard diagnostic ultrasound. This is the #1 reason for the misdiagnosis of the mass majority of fetal abnormalities. Introducing Biotics AI. Biotics AI processes ultrasounds to detect pregnancy complications earlier with improved frequency and added efficiency. In our last session, we had a live stream with an OBGYN and a pregnant patient. And what you're about to see is a real ultrasound exam processed on a real patient. We've recorded that session so you can see how the workflow works, but we're going to be uploading the ultrasound live so you can see how our AI works in real time. Move to video.
Hello, everyone. So first, I want to thank our volunteer patients for coming here to help us share our technology. Thank you so much. So I've just conducted a second trimester fetal anatomical examination using ultrasound. But what I actually did is I mimicked a low-quality scan. With these low-quality scans, key regions in the fetal brain, heart, abdomen, or limbs are usually missing. So let us see if Biotics AI could solve this very common operator-dependent procedure. So we log in, we choose second trimester, we start our reporting.
Move to demo. This is what Dr. Hisham is viewing right now. Biotics AI is a vendor-agnostic, cloud-based solution that can integrate with any ultrasound machine over a standard API. Biotics AI validated the presence of all of the standard anatomical views and structures that need to be captured, ensuring the appropriate capture of over 80 different anatomical views and regions. So that way we make sure that the patient gets an accurate diagnostic screening. What we can see here is that one of the views of the fetal brain is missing. 1/3 of patients in the United States receive incomplete screenings. When an abnormality is present in one of these views, the patient is almost always misdiagnosed. Go to video.
Okay, hello again. So feedback came indicating that there are missing planes from our scan. So I am recapturing the transcerebellar plane, and I will upload it to the system in order to see if the error has been rectified. So, image, pass it to the system.
Move to demo. Now, what Dr. Shem has just done is go back and capture the appropriate view of the fetal brain and uploaded that image. What we can see was done was our AI was able to validate that this view was now captured and then analyze the entirety of that particular view, ensuring that the key structures can be visualized so that the patient gets an accurate diagnosis. Now, our product goes beyond quality control and into guided diagnostics. The patient that we just saw is having a healthy pregnancy, and we wish her all of the best as she goes through her journey. Unfortunately, what we see here with this other patient is a malformation in the fetal spine. Biotics AI localizes the malformation, bringing it to the attention of the obstetrician, so that way we can make sure that the patient gets quality prenatal care and appropriate treatment has been provided. Move to slides. We conducted clinical studies on obstetricians that historically performed poor quality ultrasound scans, and the completeness rate of their screenings went up by 20%. Additionally, because we're automating reporting by extracting this information and generating documentation, we saved the hospital 8 minutes per patient on documentation time in these studies. Now, to build this technology, it took a world-class team of machine learning engineers and obstetricians that already had award-winning research in prenatal care, and also had extensive experience in delivering machine learning algorithms for different complex use cases. As far as our business model goes, we're using a hybrid pricing model with a subscription-based cost for baseline features and volume-based pricing for API calls. Where hospitals are incentivized to purchase our tool through the ROI we're providing through increased time savings, allowing for increased patient volume, reduction in patient callbacks, increased higher hospital reimbursements in the future through NTAP, and by mitigating malpractice costs. We're building the AI diagnostics platform for reproductive health. Our secret sauce lies in our data infrastructure, where we've been able to build one of the fastest and growing data sets of prenatal ultrasound images with access to 8 million images to date, and we're piloting across 8 healthcare institutions. The average cost of this type of project costs corporations tens of millions of dollars, and we've been able to bootstrap this for less than $100,000.
You got to wrap it up.
We're going to be expanding to adjacent markets like gynecology, urology, and neonatology, but we're starting with prenatal care, starting with a TAM of $2 billion. But through this expansion, we're going to be able to reach this vision. Thank you.
Thank you very much. Give a round of applause. And before we start the Q&A, just note that we generally require live demos. But where's your doctor located?
In Egypt.
Yeah, we're not going to make an expected mother go get a scan in the middle of the night. So thank you very much for that. If we can reset the clock, that would be great. First question, Marissa?
I might know enough to be dangerous because I had a monochorionic twin pregnancy that required ultrasounds every 2 weeks that could be anywhere from 2 to 4 hours long. So I would actually welcome anything that makes that process more efficient for other expectant twin moms. But I guess one of my questions is, are you actually diagnosing the defects? That's one question. 2, the overall size of the data set, because at least for certain types of pregnancies, that data set can be overall quite small. And I do remember at the end of those ultrasounds, we always had to wait, make sure that the image set was complete, sometimes redo it, et cetera. So my perception was not that sometimes scans are missed, it's just that sometimes they have to be repeated. So I guess my question is really, is that misdiagnosis that you see really related to the just non-existence of the scan or the quality of the scan, or just the fact that it has to be repeated?
Sure, yeah, so great. So misdiagnosis can happen for a variety of number of reasons, but the number one reason for misdiagnosis is that there are key anatomical views that aren't captured. So true, after the initial diagnosis, there are repeat screenings that are happening, but when we're talking about the initial ultrasound exam, because of that operator dependency and that wide spectrum of skill sets, a lot of patients are getting these incomplete screenings. I was talking to an OB-GYN last week that was like, yeah, I just got a screening where only 3 anatomical views were sent to me. So it's quite drastic, the difference in quality. To answer your question about the data set size and the different types of abnormalities, so the first piece is making sure that the screenings are done completely and correctly. The second piece is then in localizing those malformations. What we're doing is we're identifying a deviation from a normal structural anatomy, but we're not saying, hey, this is spina bifida or this is birenal agenesis or one of these specific abnormalities. And the way we can do that is then by grouping abnormal data and normal data for each of the standard 2-dimensional views of the fetal anatomy, and we can build out algorithms in that way. So that way we can actually leverage more data to be able to localize these anomalies.
And you're operating mostly on still images? Because I remember a lot of them had to do with things like blood dynamics, blood flow, blood pressures, et cetera.
Sure, yeah, so we're looking at structural abnormalities. So, so issues like preeclampsia or genetic abnormalities, those are diagnosed quite differently with NIPT and other techniques. 90% of abnormalities are structural abnormalities that are screened for in the second trimester, and that's where our focus area for our initial product is.
Dana?
I assume OBs love or want this. Is that true? I mean, that might be just my tech hat, always assuming that people want to actually leverage technology, or is there any resistance?
Sure. Yeah. I mean, I think, well, in healthcare, when you're working with physicians, obviously you're dealing with different types of personalities, and everyone
Yeah.
thinks like they're the greatest physician.
But you're not
But-
diagnosing, you're sort of giving them a tool.
Exactly. So
right?
we're
I mean,
co-pilot. So that's how
yeah.
we're coming in. So we're providing value to the physicians in multiple angles. So we're helping them with the quality control, making sure because of the high risk of malpractice cases and potential for error, we're making sure that they get this co-pilot so they can make sure that they're providing accurate diagnostics. And at the same time, we're providing added efficiency. So the number one reason for physician burnout in obstetrics is reporting and documentation. We're mitigating that time by automating reporting. So improving the workflow and then being this co-pilot in the diagnostic process. So the feedback has been good, but working around those other kind of cultural dynamics within healthcare. So
We'll go to Mamoon, then Mark.
Great presentation. Could you talk about the training data that you have, and what else do you need? Do you need to form partnerships with other academic centers where you get training data from?
Sure.
And then second question around just regulatory approvals for your software.
Sure, yeah. So to build out our data set, we partnered with university hubs around Egypt. So we partnered in Alexandria with Alexandria University, Tanta University, Zayt University, and then in Cairo, we also partnered with the first IVF center in the Middle East and the largest women's health center in a town called Maadi. And Egypt really has this high concentration of highly talented individuals, and we were able to actually partner with these institutions that are really eager to do this type of research. And a lot of us are myself and our CTO are data engineers at heart, so we built out the infrastructure. That was the first thing we did. We've also now partnered with 2 regional institutions in the United States to further expand our training data set and also test our data on biased data sets. As far as the FDA pathway goes, so we're going for FDA 510K. We've been working on our FDA for the last year and a half. We just finished our FDA clinical data collection as well. We actually collected twice as much data as what we need for our FDA submission, so we're gearing up for filing relatively soon.
Mark?
Yeah, I'm trying to understand if the current ultrasound manufacturers are your enemies or your friends. I'm not 100% sure. I mean, part of your defensibility is that you have this data, but if I look at GE, they have a lot of data accessible, right? So can you use them as distribution to get in as quickly as possible? Will they do it themselves? Like, why wouldn't they do it themselves? And there's also a bunch of startups similarly trying to analyze ultrasound. So I'm trying to understand,
Sure.
how do you win?
The market landscape.
And how do you win ultimately?
Totally, yeah. So as far as the ultrasound manufacturers go, like the GEs, Philips of the world,
Yeah.
they're really competing with each other, and they're not going to spend an immense amount of time on every single, because there's thousands of different specialties, tens of thousands of different types of, or hundreds of thousands of different types of indications they could build algorithms for. It makes way more sense for them to work with companies like us so they can compete with each other. So they're actually developing marketplaces. We're talking to manufacturers and different providers within the ultrasound space for distribution partnerships. So to answer your question as well around staying ahead of competition and penetrating the market, those conversations have been quite fruitful. I can't go into too much detail.
But that's great. They have a marketplace for folks like you to work with their hardware.
Yeah. Like GE
Great.
Edison is like probably the most.
Okay, so then the question is, how do you become number one on that app store?
Sure. Yeah. So the way we're looking at this is it's really important to build this like continuously growing data set so that you don't just stop with one single algorithm, but you really build out almost this network effect where with each ultrasound machine you integrate with, you can collect more data to build out new algorithms for new indications. So we're consistently scaling. So we're going to be scaling across obstetrics use cases and then into gynecology, urology, and neonatology, and really build that product stickiness with the hospitals that we're working with.
Charles?
Yeah, I was going to adding on to that, what's the current limitations on the product? Like what range of things can you detect? And I'd also just love to know, on top of the data, like without saying too much, like what is the secret sauce? It sounds like obviously you've got access to a lot of data, but I'm trying to understand exactly what unique contributions you guys are adding.
Sure. Yeah. So as far as like what we can do today and what we're going to be doing. So today we can analyze over 80, actually more recently 90 different anatomical regions and structures. So validate the entire completeness of the screening. So really you're looking at two pieces. Was the entire anatomy captured? And then was it captured with high enough quality to be able to do a diagnostically accurate screening? That in itself will mitigate a huge chunk of misdiagnosis. The second piece is then building out malformation localization in each individual plane. That's currently in research and development, but we're focused right now on congenital heart conditions and the brain conditions, and that's actually going to be part of our next release. But we're scaling across the entirety of the anatomy. As far as how we built our data infrastructure, so the way we were able to do this was really build out these HIPAA-compliant environments, set up like a real-time streaming setup where we can actually collect a lot of this ultrasound data with our research partners. We automatically, programmatically anonymize this data, remove all patient information, and then we built out algorithms internally, like AI algorithms internally that actually do pre-annotation. And then we built our own R&D team of like annotators of med students and obstetricians that then go and correct the annotations so we can actually move super fast, and our per annotation cost is less than a cent per annotation. So
That's where we're going to have to leave it. Thank you so much. You did good.
Thank you.